Welcome to Creating Your Genius.
Artlist.io.
In the maiden episode of this podcast, I want to lay the groundwork for what goes into creating your genius. As the title implies, it has a little something to do with your genetics, but as I'll get into, that's not the only piece of the puzzle. So the inspiration for this show comes from the absolute abundance of health information that's out there. I work as a health coach, and through seeing clients, I end up sorting through ridiculous numbers of studies talking about all different types of diets, supplements, exercise plans, and what they do. There's something that always seems to happen as I'm reading through these, which is everything seems to work, but everything also seems to not work at the same time. It can create a bit of confusion when I'm trying to give the best recommendations for my clients. This leads me to believe that this is a collection of truths rather than a bunch of false information. There's examples of vegan diets working for people to help heal them from their health conditions. And at the same time, there are people healing from those exact same conditions using a carnivore diet. And a vegan and carnivore diet are completely diametrically opposed. So what does this mean? I believe it means that these people made intentional choices to change their environment by way of their diet, and that those environmental changes cause different genes to become either more active or less active. The changing of your environment to create differences in the genetic expression is called epigenetics. Epigenetics is defined as the study of changes in organisms caused by modification of gene expression rather than alteration of the genetic code itself. So even though the genes don't change, there are ways to modify how the genes are expressed, which in turn causes a change in the organism. So, when person X became a vegan, they started to send different signals to their genes, causing them to become active in different ways, which produced a change in the organism, which is them, leading to greater health. So this brings us to two really important questions. The first one is, what are our genes? And the second one is, what is our environment? I'm going to start with genes. When someone is conceived, each of their parents contributes exactly half of their DNA in a random combination to the growing child. The DNA is organized into genes, which are then further organized into chromosomes. So DNA is a biological database that contains the blueprints for our cells to create proteins, and each gene is a specific sequence of DNA that is read by little machines in the cells to create these proteins. The process of going from the DNA blueprint all the way down to the protein can be broken into two basic steps: transcription and translation. Transcription is the process where the DNA is read and an identical copy of that sequence is made, but in the form of mRNA. It's important to change the DNA to mRNA because they use different nucleic acids, and the protein assemblers of the cell can't read DNA. They can only read the mRNA. The process of the mRNA being read and the protein being assembled is called translation. A good metaphor for this is cooking. Think of the DNA as looking at a picture of the finished dish. Transcription is the process of looking at that picture and figuring out what the necessary ingredients and steps are to cook it correctly. mRNA is that ingredients list and cooking instructions. Translation is then the act of combining the ingredients to make the finished product, which comes out in the form of a protein. At a basic level, proteins are the expression of life. Proteins are what allow us to take water, oxygen, food, and sunlight and create energy. Proteins can take various shapes and carry out almost unlimited functions in the body. Some proteins are what are known as enzymes that facilitate chemical reactions and make them more efficient. Other proteins take the form of cell receptors that allow us to sense our environment better. Other proteins give us structure, like our muscles and bones. It's important to understand that once a protein is made using the DNA instructions going through transcription and then translation, it can be modified through many different mechanisms in the body. An example of this is methylation, which is something that will definitely be covered in later episodes. The take-home point here is that there are ways that the body can change the expression and function of proteins without having to change the genes. The process of changing genes happens over generations and generations and generations. It's not something that happens over the course of, say, my life or your life. It happens from our great-great-great-great-great-grandparents to us, and even that's probably not enough time for any significant genetic changes to happen. So when we're trying to adjust to our environments, it's really important to be able to have other ways to change those proteins that are coded for in our DNA to make sure that we can adapt to our lifestyles. A really interesting example of this is a study from Spain in 2006 that looked at identical twins, some who had lived together their whole lives and others who had been separated either at birth or had just been apart for a long time. And what they found was the twins that spent more time together and lived more similar lifestyles had similar patterns of methylation and acetylation, which are two post-translational modifications that are applied to proteins to change their function. And at the same time, the twins that didn't spend as much time together or were separated, they had different post-translational modifications. So this shows that even if someone has the exact same genetics as someone else, there are these mechanisms like post-translational modification that change the way the proteins function, which is then going to reflect the lifestyle changes that they have. And that's a perfect segue into the environment. Simply put, the environment is anything that could have the potential to change your genetic expression. And I know that that is a very, very wide-ranging definition. So I'm going to break the environment down into a bunch of different subcategories. And with these subcategories, it's important to understand that there's going to be overlap in some of them, and that a change in one of them can definitely trigger a change in another environment. I'm going to start with the external environment, which is going to be anything that is happening outside of your body. This is going to be the air we breathe, the water we drink, the food that we eat, whatever skincare products that touch your skin, even something like viruses that you come in contact with, or toxins, or microplastics, whatever. All of these things that we're exposed to in our external environment is the external environment. Now, going from a more macro picture to micro is the cellular environment. This is the environment that's going on directly outside of your cells. These are going to be the hormones that you produce, your blood sugar levels that your body is sensing all the time, the levels of antioxidants, your nutrient status, just like how with your skin you sense differences in temperature. Your cells have receptors on them that sense different levels of blood sugar and are going to respond differently based on that. So other things could be nutrient status and immune system function, which is heavily influenced by the external environment. And you could argue that it's its own environment, but I think because of how closely it's linked to what's going on in the cells, I'm going to put it in the cellular environment. After the cellular environment, there's the mental and emotional environment. This is your thoughts, your feelings, faith, social connection to the world, spirituality, stress, purpose, financials, family life. These are the things that really impact your mood and your disposition and how you see the world. And those definitely can have an impact on how your genes are expressed. Next, we have the anatomical environment. That's how your body moves, the physical stressors that you place on it. Exercise definitely falls into the anatomical environment, and the way how efficiently your body moves can be a really important determining factor for things like pain, which is going to set off a different chemical reaction in your body as opposed to not having pain. So the way you move is absolutely important. And finally, the microbiome is something that I'm going to put as its own environment, because every one of us has an entire universe of life going on our skin, in our gut, in the mucosal membranes, and the diversity and health of this universe of bacteria is a very important part of how our genes are expressed, and it's very important for how the immune system functions. One of the reasons why our immune system developed in such a fine-tuned way as it is because we co-evolved with all of these different bacteria that still live in us. And so, because of that, the microbiome absolutely deserves its own subcategory of being an environment. There are a few other topics that are important to understand before diving into how the environment changes our genetic expression. There are some words and phrases that I'm going to use a lot that I need to introduce, especially as we get into topics like energy production. The first one is oxidation, which is the transfer of electrons or oxygens between cells. Taking a step back, during chemical reactions, there's a flow of energy in the form of movement of electrons that happens. Oftentimes, the end goal of a chemical reaction is to create the most stable molecule possible, which happens by breaking and making chemical bonds between different atoms and molecules. The transfer of oxygen is very common during chemical reactions. So an oxidation happens when a molecule becomes more involved with oxygen. This could happen in a few ways. A new oxygen atom could be added. A bond to a non-oxygen atom could be broken, which would make any existing oxygens in the molecule more powerful. Or there could be an additional bond added to an oxygen that already exists in the molecule. So these oxidation reactions are responsible for producing another important term, free radicals. Free radicals are molecules that have one or more free electrons, meaning they're looking for electrons to fill that gap. Because of the lack of electrons, these molecules are extremely reactive. They're so reactive that they have the potential to alter fat cells. They can alter proteins, and they actually can even damage DNA. And they're implicated in several adverse health conditions. So these free radicals are countered by something called antioxidants. These antioxidants inhibit oxidation and can neutralize free radicals through a process called reduction. Reduction happens when electrons are donated from one molecule to another. Antioxidants are special because they're stable, and they're stable enough that they can donate an electron without adverse effects happening to their structure. When there's an imbalance between the number of free radicals and antioxidants, this is referred to as oxidative stress. There are multiple types of free radicals and antioxidants that we will get into, but it's important to know the general topics and the potential effects that they can have on health. Having covered genes, the environment, oxidation, reduction, and oxidative stress, that lays the foundation for the most essential terms to have as a foundation as we move into different topics and what their effect on the body is, to help, give you the information to make the most intentional choices about your health. The general theme is going to be how health impacts genetics and the environment, but there's a ton of brilliant people in the world who have so much to share. So there are going to be guests coming on, and when I have guests on, we may go through topics from a different lens and explore things in a little bit of a different way than just through the environment and genetics. So with that all being covered, thank you so much for listening to this first episode, and there will definitely be more to come.
Artlist.io